Okay, so 3.11 through 13 sections all relate together. So I'm going to talk about each, but they're very heavily related together. If you notice, Unit 3 had like chunks of different things related together. You had your gases and then solutions, and now these ones are going to be together. So here's the first one. Now, we've talked a lot about this already. We talked about the duality of electrons being a particle and a wave, and then there's a couple things you need to know that I either didn't mention or you might have forgotten from Unit 1. So, one thing is you need to know red is longer in wavelength versus purple being shorter. You could see that in this diagram right down here. And so, ideally, you should know what wavelength red is at versus where purple's at, and then kind of guesstimate the other colors. So I have seen MCQs where they asked you, hey, calculate the, I don't know, the energy of a purple color wave. And so they don't even give you the wavelength, and so you had to assume you memorized it. So technically, you need to know that. Unfortunately, yeah. There is also the relationships between short wavelengths versus long wavelengths. I'm going to see if you can figure it out first. So I would actually pause this video, look at your constant equations sheet, and then see if you could figure it out. Or you look at your notes from before, because we did write it down. Alrighty, ready? So shorter wavelengths have a higher frequency and higher energy. Longer wavelengths have a lower frequency and higher energy. Again, you could memorize this if you want to, or you just have to look at the equations on your constant equation sheet to figure that out. Or you could just draw a wave, to be honest. Like here's different waves and their different lengths, right? And so if you draw the different lengths, you can see how frequent it is. Like you have a short wavelength like these guys down here, well, your frequency is going to be hella because they're just going to be, bam, 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 bam. Versus a longer wavelength, it takes longer, less frequent, right? And then energy and frequency just have a direct relationship. That's how I personally remember it, is just drawing it. But you can also, again, use the equations or straight up memorize it. That's up to you. You need to know the visible spectrum, like I said earlier, for this bullet point. So this is the approximate range for this. So purple's 380, and then red goes up to about 750. And so then you can guesstimate the colors in between in case you get an MCQ that doesn't give you wavelength but does give you the color. So you should be able to calculate that. Don't forget to change your unit from nanometers to meters. You should know where microwave waves are at versus where ultraviolet rays are. And so you could see that here, ultraviolet is this way versus microwave is this way. So microwaves are long versus ultraviolet is short. Random fun fact. If you have ants in the microwave, for example, like your literal microwave, the one you use in like a kitchen, for example, and let's say you had ants in there, and so if you were microwaving some food and you didn't notice ants were in there, the ants don't get fried. Your food does, because it's getting reheated and whatever, but ants don't. The microwaves, the literal microwaves, are way too long and don't affect ants. So random fun fact for you. Gamma rays have the shortest wavelength. Remember that lambda's wavelength, highest highest frequency, and then radio waves being the longest wavelength, lowest frequency. Know those. Because again, I've seen some MCQs related to that. Yeah. All right. So other stuff to remember from before, remember photons are carrying that light, and that, like the visible light that we see. Obviously it can carry other kinds of energy, but light we see when it goes from excited to a less excited state. So, yep, just remember that. And then here's some new stuff. Here we go. So, there are 3 types of spectroscopy to know. We have infrared, that's what IR is, And infrared is used to find the number of bonds in a compound. So if I have an unknown compound and I want to figure out if it has double or triple bonds, I can use infrared in order to do that. We have the visible kind of spectroscopy. So we have colorimetry, which is, literally as it sounds, studying color. We've definitely did similar stuff before. Kinetics, which we'll talk about more later. Getting any kind of color from stuff. So like brass is an alloy, copper has specific color compared to the other compounds in brass, and so I could detect that using visible. And then food coloring, I can detect food coloring in certain solutions. And then X-rays are the PES graphs, so that's this guy right here that we've talked about before, but I don't remember if I mentioned they were X-rays or not. So here we go, X-rays. Make sure you remember how it works, so review that Unit 1 stuff. We're using the energy scale to see how many how much energy it is to take out the electrons. So first we're removing the valence, which is the most right one, and then we get closer and closer to the other core electrons. We're measuring that kinetic energy to make them escape. So here's our PES spectrum, our PES graph, so just remember that. So we have the 3 kinds of IRs you need to know. Cool. Alrighty, so this diagram is showing what we can, the energy for photons. So this is the equation we know from before. And so we can see absorption or emissions of these photons if we need to. Cool. Remember that when electrons are transitioning between one energy state to another one, we can see that again based off how it is, moving around and stuff. So for transition of electrons, we have microwave radiation. And so this is a transition in molecular rotation levels. Do you need to know what exactly that phrase means? No, but you do need to know microwave radiation is for transitioning molecular rotations. I mean, it makes sense in terms of if you break it down, because like with anything in science, they tend to use words that make sense or prefixes and stuff. So molecular being molecule, rotational being literally rotating. So rotating the molecule in space, right? And so that's what it's used for, is seeing those transitions of literally rotating the molecule. We have infrared radiation. It's for vibration levels in molecules. So there we go. And then UV or visible radiation, we can see this electronic energy level stuff. We could see the electrons moving from one thing to another thing. And so that's some other random crap to memorize, unfortunately. What the heck these two are is way, way complicated for this class. You'll learn about it in Upper Div Chem if you take Upper Div Chem. For now, you just need to know this. Cool. We use all these things to see how molecules interact in, different reactions. If we have some unknowns, for example, we could see things like potentially combine and then see what kind of products you're potentially making. That's what it's used for. So, for example, if I wanted to have some kind of drug and I wanted to see how it would react to a specific compound in the body, if I just want to focus on that compound, I could put those two things together and then see what kind of products are formed. And to see exactly what products are formed, I can use these various things to determine the exact products that are for sure being formed. Because even though we have predictions we can make based off patterns and stuff, you need to verify it using, lab techniques. And so that's what this kind of thing can happen. Just what kind of interactions those molecules can have, or other kinds of particles. So you need to know the radiation types. So here are the different types. So I mentioned a couple of these earlier, and then you need to know how they relate. What probe they are. So microwaves are molecular, IR is molecular vibration, rotation. I've definitely seen some MCQs related to this. So again, just radiation type to aspect probe, pretty much know that chart. You don't need to know this middle section. I haven't really seen questions that are related to it. Granted, if they give you a value, make sure you can plug it into your equations that we learned from before. Cool. So that's it. Like, again, just memorize this, essentially. The radiation types, aspect probes. Okay, bye!